Hello, everyone. I'm absolutely delighted to be here, even though I'm probably not exactly part of your industry. I mean, I'm an analytics practitioner, data science, but more in the commercial corporate world. So I do not specialize in particular solely on quant investing, but I'm here to give you maybe a slightly different perspective as to how we see that market moving, and a general high-level keynote scene-setting presentation. So if you are really more onto the algorithm, the how to do, and the nitty-gritty of the detail, it comes more into the next presentation. But I hope you find it very entertaining. So presentation is in 4 parts. I'm going to try to go quite quickly on each slide, because I only have 25 minutes. And there's loads of material, but I'm happy to take a question at the end, or you can come and talk to me at the break. First part, talk about a bit more detail on big data and the evolution of analytics and what it means, expanding on some of what Armando has just been saying. Just do a recap, a very high level, what we mean by sentiment analytics on new stream, and that's sort of already here. And then trying to look, and this is, so I was thinking outside the box, as to what else there is that actually is currently being used for quantitative trading or research in big data. So we're not talking just structured data. And then finish off by how do you start and how we help organization on that journey with some pointers around capability and maturity assessment that might be relevant for your business. Yeah, so first section, I'm sure none of you, or only very few of you, have heard about Atos, so I'm just going to spend 1 minute talking a little bit about us and pass very quickly, talk about the evolution of analytics, how it allowed to measure and manage much more effectively than ever before. And that's why we mean it's a management revolution more than a technology revolution. How do you enable the concept of this data value chain, and really focus more on 6 trends, what we see from this year and onwards around the big data space. So we're one of the world's largest system integrator and IT service company. We have a strong presence in financial services, but more on the IT services, managed services end of it. So we probably, from the 7 biggest banks, I think we manage the data centers, the hardware, the application management, some of the high-performance computing application and big data application from a hardware and software with the Bull acquisition. We deal in digital transformation, and we have solution across the entire value chain. One thing we're famous for is the Olympics. So since 1992, we've been managing the entire IT of the Olympics, which means setting up a quite complex IT organization for only 3 weeks with lots of pressure and dealing with lots of people. So that's one thing Atos is good at, is orchestrating that complexity. So Atos Consulting, which I'm part of, is only 1,500 people of the 88,000, which deal more at the management business consulting front end. Okay, so the evolution analytics, I don't want to spend too much. I'm sure a lot of you have been bombarded about the explosion of data, etc. But what has changed is we constantly produce more and more data, and more of that data is, as Armando was saying, unstructured. Yeah, so very unwieldy, lots of different formats. It's huge volume, and it's produced at a really fast rate. So that has triggered, and you can see here, a need of a different set of technology required to process and analyze. And also opened up, and this is what we want to talk today, new source of information to be able to make decisions. Yeah, so, and again, this is not intended here to be exhaustive in terms of physics. This is a high-level picture. We'll go into more detail. Clearly, one idea, and this is a quote from Google, saying it's nothing new about algorithm. Algorithms have stayed more or less the same. Well, some people might put it otherwise, and there's constant research, but the fundamental of the maths haven't changed in the end of the 80s or beginning of the 90s. So when Google say they can do better things than others, it's not they have better algorithm. They maybe use even simpler algorithm because they need to scale, but they have much more data. So the idea is to move from just that structured data, which is in tables and really well understood, and still not completely exploited, by the way, by most companies. It is very much exploited in your industry, to what they call machine data, something which is semi-structured. So you can think email as being maybe semi-structured, and it doesn't have a header, a timestamp, a log, to something which is completely unstructured, which would be human-generated data. So all the way to a post, a news, a blog, a document, etc. So the idea is to optimize it. So why is it a revolution? Because it's really sort of a perfect storm of new type of data combined with the need to compete analytically, the possibility through, in particular mobile devices, to have new business model that are derived from value that the one adds to data, and also an agility and customization piece around massively parallel, cheap, large-scale technology. So this impact is not just felt in your industry, it's felt in every single sector. And typically the focus is on data monetization. So you collect data for a certain purpose, which might be the primary usage. For Google, it's just facilitate giving you a search back. But then the monetization comes from the secondary or the tertiary usage of it. So in a sense, it's not just thinking about your own business, but what you could do with that data and create new value streams. So this is what we call the data value chain. So most people rush into it by looking at, I'm going to look at the technology, hire some data scientists. We firmly believe, and the idea is to start with the use case and the value. So you start with that end of the picture here. So if I was thinking I had one use case talk, program trading or risk management. So this is the kind of use case we're going to talk more today. And from those use cases, you look at, okay, what is the analytics use case? So what kind of business function will be affected, and more precisely, what kind of type of analytic application you're going to have. So obviously for quantitative investing, if we're taking trade setup strategies, we're talking about predictive analytics mostly and more prescriptive analytics. So what is the optimal decision at a single point in time to manage my risk? On the other hand, you have all this data. So big data, you can say, very high-level summary, it's either big, very, very large volume, or it's fast. It comes, and the beauty of what RavenPack does is both big and fast. So you have news, there's loads of them, and you need to analyze them very, very quickly. So that's what's different, and something you can't just do on a laptop, on a server. At the heart of it, what you have is a data analytics framework. So different bricks of technology that you need to be able to do this, from the acquisition to the transformation and management, to the modeling and the analysis, all the way to the presentation, the scoring, the visualization, the consumption of it. No matter which vendor tells you, nobody has all the elements of, so you need to have an open framework and to combine the right brick depending on your use case. So that's why we work with a partner ecosystem. I already mentioned a little bit that. The whole idea also, if you want to go fast and work in an agile way, is to be able to stand up those kind of platform and those components fairly quickly. But I'm going to pass on that because I'm running late on my agenda. So the 6 trends that we see, and this is going to be of interest to you, I hope. By the way, they're not just mine. They are the International Institute of Analytics and then the IDC. But they're fairly sensitive. They were written beginning of this year, so they started to be dated, but they actually have realized. One is Internet of Things, sensors. There's been a lot of focus about connecting devices, connecting machines, connecting vehicle, applications. The focus is moving more now to what we call the analytics of things, the strategies that are required to make those devices intelligent. Buying and selling data, this is RavenPack is effectively a data provider to the quantitative investing industry, is going to become really bread and butter. The forecast is that by 2019, 100% of all business will buy data and will also sell their own data. So maybe a challenge for industry is you're a large consumer of data, but could you think, and maybe it's not for the just the quantitative investing part of the industry, could you also sell or monetize your data? Image, video, audio analytics will become more pervasive. One of the series of use cases I'm going to talk in a minute talks about using image. We're talking about the skills shortage. Who has this mythical unicorn that can be a business expert and a data engineer and a data science and programmer and a communication expert, etc. So there is a need and a focus on trying to make those type of information more easily available in the form of self-service and more automated. And that means 2 things. That means for organizations reorganizing the way they work in a quite a profound way, and very often that's the blocker in having that innovation. And the second also, it means people that are not necessarily data literate upskilling themselves, because if the system is really sufficiently transparent, sometimes you need to go under the hood to troubleshoot. Communication is one also a key element about the result. And finally, the big killer app, if we think in terms of use cases and where the industry sees value for big data in particular, not necessarily just quantitative investing, but much more on the security. There's been some prediction that says security cost will be higher that will become actually a negative impact on GDP because it will be so easy to attack and disproportionate cost to protect yourself. But there's a promise to leverage that data to actually combat it. Okay, so that's enough for the bigger scene. So here today, I mean, all the other presentations seems to be focused more on the concept of news analytics. I mean, in large news analytics. By news, we mean also social media and form of content that can be aggregated and inferred to produce meaning that will be useful for in additional with other data source to make a trading decision. So, open web social media, and it's about turning it into a structured feed. So you can use it in your quantitative application in your modeling. So we're talking here doing a real-time linguistic and sentiment analytics on financial news. I'll come back in a second what this involves, and I'm sure the colleague that are presenting afterwards will go in much more technical detail, and you could also ask them some questions. But typically, there's two uses of those techniques. One is around sort of more higher frequency, short-term trading, around reacting very quickly on news. But that's potentially not the best use. It's only one of the usages. The other one is to actually maybe to go a medium or longer-term view and derive sentiment-based indices, either based on a company, either based on a country, or on a commodity. And the art here is about how you construct it. So maybe technology like Dow Jones, RavenPack, some of their competitor. As well, I'm not technology agnostic, so I should mention, but Thomson Reuters also has some solution and some others. They provide with bricks, but it's up to you to actually integrate them, and that's the art. Now, this is a bit of a joke. Some of you may have heard of this. It's called, it was nicknamed in 2011 the Anahata Way Effect. Some people were starting losing social media, and if you don't do your entity extraction properly, you say, oh, Hathaway, bye. Now, but it did work. You would do the correlation was there, and people were making money. But is it just self-fulfilling prophecy? Because there's no causality. If you have positive news on Hathaway, why should Berkshire Hathaway stock move? So it's probably disappeared, those effects, but I'll be sure maybe our colleagues have even more juicy story. But this is interesting to see that there is that feedback loop in trading, which means things that shouldn't be working do work until they don't. And being aware of that is important. And this is absolutely the case in sentiment trading. So here, mention unstructured data converted to structured data, so it's exploited by machine. Automated event detection, so it's about both schedule event and be able to score them, whether they are positive or negative impact, expected or neutral, but also unexpected ones. And that's where the reactivity is important. Now, if you think about and you go a bit closer, an event is not just once. It's probably repeated 1 million times in different sources. So you need to see, is it really a new news or is it old news? And be able to detect for that. And that's it's been more difficult to do. Another problem is around entity detection. So, IBM, Big Blue, Internet Business Corporation. So there's a lot of different ways of representing the same entity. Then it also is actually the information correct. So, so maybe Dow Jones Newswire from a press agency, well, you can rely on them that they're probably going to be true. Social media or the source might be less true. So there's more around opinion. So how do you factor that in? The influence of the source as well. So if somebody very influenced propagates a news, it probably will have more impact and bigger reach than if it's just somebody less influenced. So be able to map the network effect is important. But at the heart of it is about that sentiment scoring around relevance, novelty, and I'm sure this will be explained again in more detail, and you probably read about it. There's no silver bullet approach. This combination of two approaches. One is around using ontologies and taxonomies and defining the context based on subject matter expertise. As if there's a merger and acquisition, I know this is definitely impacting this industry in that way. So I'm going to define and codify what is the impact, and also how do I measure merger and acquisition and the different types there is to a very specific taxonomy ontology, and I try to extract that from that data. On the other hand, you have the purist from the machine learning and the data miner say, well, I don't care what the topic is it predictive of a better return? Is it, so that's the Anahata Way effect. I don't care, it's Anahata Way. It predicts Berkshire Way, so I'm going to use it anyway. So you need to combine both to find which topic are more important in terms of predicting, but still controlling for the fact that they are relevant and part of a taxonomy. And that's not just on text, it will be the same on image. There is a lot of noise. And the last thing, and not the least, which is absolutely key for short-term trading, is speed. You only have a few milliseconds. So I know a couple of years ago when I was talking with my friends at RavenPack, they were looking into even hardware acceleration, so able to actually encode and score that stream through a chipset to go faster. Now it's probably done in memory or to complex event processing technique, but it's a really data engineering which is quite advanced and strangely pioneered in the telecom industry. Which is about making calls and allowing more bandwidth for the same cost. And for those that have read about high-frequency trading and being closer to the exchange, those were some of those techniques were born. So speed is important. Okay, so that's sort of fairly the topic of the next few interventions. Now I wanted to throw out 3 new things that some of them, obviously, I think you will be familiar with. The first one is around, well, there's other data you can use. So it's not web search query data. It's not about the text, the post, the content. It's what people search for and when they search it and where they search it. And this is, again, pioneered by Google, but there's also other source provider around other search engine that tell you, can you incorporate that information to make better predictions? So see example in 2008, 2009 about unemployment. So, and typically you have a time series. You can look at the initial claim being filed as being a lead indicator to the end of the recession and factor in your time series, and you get certain results to predict what is likely to be the unemployment rate, in a certain window in the future. What you can is look at who is searching for things like, Monster, LinkedIn, Hot Job, food stamp, Social Security, etc., and aggregate all those search. And what has been proven is this produces an improvement in your model. Typical procedure that I've described is you start with the time series you've got, and then you incorporate those additional time series. You will have access to the presentation, so I'm not going to go through all the steps. So important thing to consider is that you get more granular frequency than what you're trying to predict, usually on web search query data, so you can have it daily. If you pay Google, you can even have it to the level of granularity that you want, provided you don't breach privacy. What is important is also, and I'm going to repeat that again, context is very important. So if you search Apple in the context of making a query about fruit, it's not the same as searching for Apple as a technology company. And that's also provided by the web search company. So now, this can be very sophisticated. So you've heard probably of flu trends from Google. This was the idea that we can measure the dissemination of flu in the US and actually in many, many countries by looking at the CDC, the Center of Disease Control. They have a lag of 2 or 3 weeks to get the result because it needs to go back to a sample, a survey, and goes to the GPs, etc. So here it says if we look at people that search for flu-type search, can I predict it? And not only I can predict it quite accurately, I can predict it much earlier. And it was hugely successful, and it was pure machine learning. So they didn't start to understand why it worked. It was a very complex ensemble model looking at lots of different combination of keyword searches. And it worked until it didn't. I think it's 2011 or 2012. Even though there was data scientists, they had done their modeling properly, out of sample testing, robustness, etc. What has happened here is something else had happened, is that there was a bird flu scare, or pig flu, some kind of. So people were searching for flu not because they were sick, but because they were interested in that other event. And that has completely thrown away that pure machine learning approach. So again, that balance from being human supervised versus using the machine is again very important. And even the best people at Google got baffled by that initially. Okay, have you heard of the Macroscope? This is the idea of using satellite data. This is not new. The military has been using that for years. I remember the days of was it the Gulf War or Iraq War, and you were trying to detect tanks on machine, and I was working in a consultancy that was providing that kind of services to the military. And here, you can absolutely detect, for example, if there is a certain. The idea is that if you can do it now with fleets of satellites that pass the same area, I mean, of course there's cloud and weather and other things, but you can monitor every 90 minutes or every hour, or at a much higher level of resolution and frequency, the same area of land. So you can see what's going on. Now this is not just R&D or theory. This is being used, for example, to have estimates, better estimates, early estimates of GDP for countries that have very poor statistical collection, using how much light there is at night and how those things evolve. Similarly, looking at transition from rural to city in Kenya, for example. But in China, somebody is actually tracking 6,000 different industrial facilities, how many trucks are coming in and coming out. So trying to almost read, without having access to that company, how much order they're having, how much they're selling, and try to then aggregate all of that across all that industry to get almost a purchase manufacturer index. And finding out that you can find that it's actually below 50 when the one published by China is above 50, and then that means the outlook is not positive anymore. There's similar things on looking at car parks and trying to predict turnover or profitability of shops, like the Macy's of the world, or also the big shop, and particularly when there is this was done by the MIT. You actually get a faster and sometimes even more accurate estimate of the sales. And this is used already by hedge fund, bank, and governments, but probably it's not as mainstream as news analytics is. And to people in industry say it's the real game changer. Potentially we have the technology available to do that as fast as we're doing from news, and potentially is as good as an image is. So you can almost say, if I could do an image every second of everyone in the world, you would know everything. Well, we're not there yet, but that's the direction it's going. So certainly at an aggregate level, it is very powerful. So here, those are the list of all the use cases for Earth observation from Surrey Satellite Technology Limited, this company here. In Atos, we do all the monetization of the data from the European Space Agency. So we actually manage the platform that provides the access to that data. But it's mostly used in agriculture. So you want to do where crop pests are, or things that are difficult to monitor. Before that, you need to have planes to go on it. Forestry or disaster, also maritime. So defense and security, obviously, this is where it started. But risk management as well, urban growth, mining, oil and gas. There's a lot of industry which are using it, which means if you're a quantitative investor, you can also use it to know how well they're doing, irrespective of what their financial statements are, or if you see discrepancy. So this is really an area which is only going to accelerate in the research first, and then also potentially will hit quantitative trading. Okay, the last one is a bit more controversial. No, it's true. So you've heard this was 2 or 3 years ago that some researcher was saying with feeds and usage of a mobile phone, you could, with 87% accuracy, predict if someone has depression. So that's what I think Armando was talking about, digital footprint. Now, what other people in the industry are using is, forget about the algos have gone so far as they can go. Forget all what you're doing. What we can optimize is the human optimization. Now, are you trading in the zone? So we're going to put sensor and try to link stress and physiology back to performance. So this looks like a gross invasion of privacy, and some people may disagree with morale, but it's nevertheless being tested and taken very seriously. And this is not new. This is coming from the field of sport. So there's been a revolution in sport. You've maybe read about Moneyball and having statistics to manage play. But now they have sensor in their shirt. They measure instant speed. If a rugby player starts slowing down, he's taken off because he will have an injury if you leave it on. So that kind of performance in athletics and sport is coming also into trading on the trader and on the trading floor. Okay, and I have 2 minutes left. So, but if you look more wider, I have all the reason why it could go wrong and what you need to get right if you want to progress as an organization to be more analytics driven. Now, this is a bit of a challenge talking to quant investing because that's what you do. And on that core side of the business, it is the business. With this being said, here what you have is, this is done from research, the white paper we just recently published. I look at 9 different distinct dimensions that an organization needs to get right if they want to become truly analytics and data driven. And they are all sort of independent. You can get any of those wrong and you will have a problem. And very often the problem is not in the data scientist. It might be in the culture. It might be in the operating model. It might be they have the wrong data strategy. It might be the technology strategy is flawed. Or the performance and risk management framework is not correct. Or there's securities issue and compliance issue. So you need to consider all of those. Some are more important than others and they start in an order. What we've developed is ways of actually assessing and making diagnostic to understand where the problem is, which is very useful when you start to address certain questions typically our clients have around, is it possible to improve our modeling? We see more consumer model. What do you recommend? I'm not sure about the quality of my output. How do I get to the bottom of what's happening? And very often, for two different companies, it will be a different era which will be triggering the problem. Okay, I'm going to pass on that. And finally, also, well, you need to have analytics capability. So that's a little bit of opening the bonnet on some of the concepts that we take in more detail earlier. But moving from data to information to knowledge to actually wisdom or intelligence require a set of capability, both in terms of acquiring the data, in terms of managing it, storing it, analyzing it, visualizing it. And what we map here, whether they are sort of big data, MapReduce, parallel distributed data management, or in memory even faster, versus it's more data science, machine learning, platform engineering, visualization engineering. And what is sort of deemed to be now, it's variable by industry. You obviously probably will want to be more advanced than others. Minimum, basic, intermediate, or advanced. And whether you have this in open source or it's more specifically vendors. So you're free to read that. And if you have any question, I'm here and I'm happy to take a question. Thank you.
With a mic, if anybody has a question, just raise your hand. So I have one for you, Nicolas.
Okay.
So I'm curious to understand, how do you go about, as an organization, how do you go about determining whether you're actually a data-driven company? And more importantly, how do you go about truly identifying yourself as a big data analytics company?
Yeah. When big data, I say, is means to an end, so I would park that one, because small data might be enough. It's any data, as we were mentioning. You need to look at, are you strategic about the analytics? So what are you going to use the analytics for? So the use case, and whether you aligning your objective to what your business objectives are to create competitive differentiation. That's the key aspect. And then how well you have defined your use case. I can have a use case, solve world poverty. That's not very well defined and quite hard to achieve. Yeah? Versus something which is very specific. So it's one thing saying analytics for quantitative trading, but what exactly, which source are you going to use? What kind of strategy are you going to apply? Which instrument? How are you going to combine it? And mapping all out. Well, then that drives into what kind of, how you will integrate back into the trading system. Is it still going to be a manual decision? What about the culture of the trader? Then it maps into what's the operating model for the discovery, creating and inferring the model versus its industrialization, and what's the role of IT versus more maybe the data scientist. Then it's moving on to what kind of skill set do you need. So is it more automated, but does it require some level of data literacy from the operator, the trader, for example, or the risk manager, versus and how much of the data assets they are? Where do you sit them? Do you sit them with the business, or do you sit them centrally? It's how this is governed. And then it moves into the data strategy. So which source are you going to go? Now, this may think, I'll throw you satellite data and social media and blog. You can spend years analyzing this with no value. So where are you going to start? How are you going to incrementally prove which one is more valuable than the other without breaking the box? Well, you need to work with partners. You need to work with people that are already prepared that can allow you to explore and test much faster. So there's a whole process on that. And then you move into the process. So agile processes, what's your lifecycle management and performance framework. And then you shouldn't forget, maybe less so for quantitative investment, because you deal more in aggregated data or business data, but privacy is very important if you're thinking about connection and sensors, and also security. So you don't want somebody hacking your algorithm. So if you increase your security, you become more data-led, you use connected, you have a potential to be infiltrated as well. So you need to consider all those things, and this is what the model is about. But doing it in the lens of a business, and start with a business question.
Perfect, great. Thank you. Nicolas, Mallison, everybody.